As we continue our study into trigonometry, and just before we get into SOHCAHTOA, which is sine, cosine, and tangent, we're going to consider special right triangles. And there's two types of special right triangles. There's the 45, 45, 90 degree triangles, and then there's the 30, 60, 90 degree triangles. And first, we're going to stop and take a look at a 45, 45, 90 degree triangle, and we're going to be considering how these angle measures affect the length of the sides. So here we have our theorem of the 45, 45, 90 degree triangle theorem, and it says in a 45, 45, 90 degree triangle, the legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of a leg. Now, when we're considering right triangle trigonometry, one of the first things we need to do is locate the hypotenuse. And the hypotenuse is always opposite the right angle. So here, this line segment AB is the hypotenuse, and we see that its length is L, one of the lengths of the legs, times the square root of 2. Now we also have a leg here opposite this 45 degree angle, and right now it's showing a measure of L. It's a leg, and the second leg is opposite the second 45 degree angle, excuse me. And since they're both 45 degree angles, these legs are going to have the same measure. So let's use this information, and we're going to find the length of the hypotenuse in a 45, 45, 90 degree triangle. So here we got three triangles we're going to consider, and we're going to start here with 1A. We see that it is a 45 degree angle here with a 90, which means that this angle here is also going to be 45 degrees. So it's a 45, 45, 90. We're going to locate the hypotenuse. It is directly across from the right angle. And right now it has a measure of x, and we're looking to find x. So if we remember, the hypotenuse is equal to the length of a leg times the square root of 2. So this is pretty simple. This length of this hypotenuse is simply going to be equal to, hypotenuse is going to be 4 times the square root of 2. Now, before we move on to the other two, let's just prove that that's the case. If this is a leg and this measure is 4, then this is a leg here and its measure is also 4. And if we were to use Pythagorean Theorem, well, let's see what we would get. Let me see if I got a little room to work with here. Well, we know Pythagorean is a squared plus b squared equals c squared. And a and b are the two legs. That's the measure of the two legs. So if I am substituting 4 for both a and b, I've got 4 squared plus 4 squared equals c squared. And 4 squared is 16. So then we've got 16 plus 16 equals c squared. Well, that's 32 equals c squared. And then we take the square root of both sides. So we got 32. Square root of 32 equals c. And in 32, I'm looking to see, okay, is there a perfect square inside of 32? Well, 32 is the same as the square root of 16 times the square root of 2. And what is the square root of 16? Well, the square root of 16 is 4. So this is now 4 times the square root of 2 equals c, which is the hypotenuse, and Shazam, that's the same answer we got there. Now, let's look at 1b. Again, the first thing I want to do, I want to locate the hypotenuse. It is directly across from the right angle, and so x again is the hypotenuse. And I have two leg measures here, 5 and 5. Now I don't have any measure for these other two angles, but since this is 5 and 5, I know that these must be 45 degrees because they have the same, the sides have the same measure, and then therefore those two angles are going to have the same measure. And if there's 180 degrees in a triangle, and we know one of those angles is 90 degrees, that means there's 90 degrees for the other two, and they are going to be congruent. So I can take the 90 divided by 2, and that's 45. So they're both, so we have a 45, 45, 90 degree triangle. And again, x, the hypotenuse, is equal to L times the square root of 2. And one of our leg measures is 5. And so x, the hypotenuse, is equal to 5 square root of 2. It's pretty simple. Now, this time, what do we have? 1C. Well, I got a 45 degree angle, so that tells me that this has also got to be 45 degrees here. I'm going to locate the hypotenuse. It's directly across from the right angle, so it's x. And one of the leg measures is 7 square root of 2, means this leg must also be square root of 7 times the square root of 2. It's got to be the same. And so let's see. Again, x, hypotenuse in this case, is equal to a leg length times the square root of 2. Well, this leg length that we know is 7 times the square root of 2, and that's again going to be times the square root of 2. Here's the L, here's the square root of 2. Let's see, the square root of 2 times the square root of 2, well, that's 2. And so x is equal to 7 times 2, and 7 times 2 is 14. And so the hypotenuse in this case for 1C must be 14. All right, well, next we're going to find the leg lengths given the hypotenuse. We'll do that in a moment. Be patient and get plenty of practice.